Okay, so I'm just gonna refresh your memory real quick on how to do long division with polynomials. Now, before we do any of that, so I just gave you this sheet here. Before you even read, don't even look at anything. Let's just see if you remember how to do long division just with normal numbers. Let's try and divide, I don't know, how about 15 into, oh, I don't know, how about 43,293, whatever. See if you remember how to do that. Go ahead, everybody try it. Long division, no calculator, pencil and paper. Yes. We're gonna just. See if you recall those steps.
How many times? 32.
Oh. 8 apparently.
Yay! What is? Oh, I didn't even put anything in. It's 0.
Mm. All right, so let's recap. Jake? I have no idea. It sounds right. I didn't do it. I just made up the numbers.
Yeah.
How did you do it?
Okay, let's talk about it. Here's what you ask yourself. 15. 15 can't go into 4, so then I turn this into 2 digits, 43. I asked myself, how many whole times can 15 go into 43? And that answer would be? Twice. So I put a 2 up top over right, my ones place of that digit. And now I do what with that 2? What do you do with the 2? Yeah, you take whatever's on top and you multiply by what's out in front. So 2 times 15 is 30. And then what did you do? You subtract. Exactly. So you bring this down, that ends up being a 13. This number should always be smaller than that one. If it's not, then you should have gone higher. And it certainly can't be negative because then you went too high. So then I bring, oh wait, you tell me. I bring down the next digit. So now I got to ask myself, okay, how many whole times can 15 go into 132? And what did we decide on? 8. So again, you have to do 8 times 15. So that's going to be a 0, carry the 4, 120.
Yep.
And then what's the next step? Subtract again. Exactly. I end up with a 12. Bring down the next digit, which is a 9. Another 8. We already know that's a 120. Minus, bring it, I get a 9, bring down the 3. And what's that? 6. 6 times 15 is 80. Oh, it's 90?
Right.
60, it's 90. Minus, I get a 3. Now, what you do with, at this point, it depends on like what level in the like elementary school you were in. Because sometimes, do you remember saying like remainder 3? Yeah, sometimes you would even put like R3. Or if you were advanced enough, you would go into decimals, right? You put a decimal place and then you keep going. We're going to stop here. Another way to write a remainder, I don't know if you remember this, but you could say, I have 3/15 left over. So whatever your remainder is, I can just put that over whatever I was dividing by. So 2,886 and 3/15 should be my final answer.
That's pretty good. They have like different parts. Like you would switch. Like sometimes like based off like how you get your homework.
Oh,
So if you get that, you would,
every day?
yeah, it's switched literally every day. It was so much
Oh.
damage. I hated it. Where'd you go to school?
that?
Yeah. It
Regardless of how your experience was, everybody has a basic remembrance of long division? Perfect.
Three.
Well, you'll remember it on Monday when I reteach it to you. So let's talk about long division. You could certainly read through all of this if you wanted, but I'm just gonna sort of talk my way through it. So I'm gonna do, they give us an example problem up at the top here. They want us to do that whole big polynomial divided by x minus 2. Remember, whatever you're dividing by is the thing that goes on the outside. Do you guys remember the names of the things?
Dividend and.
Which one's which though?
Divisor.
Yes, the thing on the outside is the divisor. The thing on here is the dividend. And the answer is the
Quotient.
quotient. All right, so to set up a polynomial for long division, you want to make sure first that everything is in standard form. If it's not, so your highest degree first, then work your way down. If it's out of order, rewrite it so that it's in order. Do you remember the other really important thing to remember? I'm just going to recopy how they have it up there so I can kind of do it out. Do you remember the other thing you had to remember with these? I'll give you a hint. It had to do with 0.
Can't fit a number in equal to 0.
Yeah, if any of your degrees are not represented, then you put in a 0 placeholder. So if I look at mine, I have x to the third, and then I have x squared, I have x to the first, and then I have just a constant. Everybody is represented. If I had gone from x to the third and then like skipped over to just x, I would have put in a 0 placeholder in the x squared spot because I want to keep everything aligned. I want to have all my x cubes in one spot, all my x squareds in one spot. So we need to put in 0 placeholders if any degrees are missing. In this example, none of them are missing, so I'm fine. Everything's in standard form, so I'm ready to go. It's a little bit different. I mean, the process is kind of the same, but I ask my question of myself a little bit differently. I say to myself, I just look at this first term here, x, and I say, what do I need to multiply that by to get this first term? 2x cubed. So what would you multiply x by to get 2x cubed? 2x squared. So that's what's going to go up top. And I make sure that I put it in the x squared column. Everything here is going to be all x squared. So I put 2x squared up top. But now, just like I was doing when it was numbers, whatever was on top, I multiplied that by whatever was out in front, and I wrote it underneath. So check this out. If I do 2x squared times x minus 2, you're going to have to do it times both, right? So 2x squared times x is 2x cubed. I'm going to put it in the cubed column. 2x squared times a negative 2. Isn't that a negative 4x squared? See how I'm writing in the x squared column? You see that? Everybody see that? So I took what was on top and I multiplied it by what was out in front and I wrote it underneath, lining everything up. What did I do when it was numbers? Once I multiplied the number on top of the number out in front and I wrote it underneath, then I subtracted. You need to subtract all of this. So now I have a minus, and when I do minus a negative, doesn't that turn into a plus? Do you see that? When you subtract that whole line, now look, this first term should always cancel out. That's math looking out for you and saying, yep, you're doing it right. Keep going. You're doing great. Now over here, I have a negative x squared, 8x squared plus a 4x squared is a negative 4x squared. Right? And then what do you do? What do we do with numbers? Jake? Yeah, I'm going to bring down the next term. So I'm going to bring down a plus 9x. And then I basically just repeat the process. I'm going to ask myself, what would I multiply just x by? Just whatever that first chunk is. What do I multiply that by to get negative 4x squared? What do you multiply that by to get that? negative 4x. So I put it up top in the x column, negative 4x. Watch your signs here, be careful. Now I need to take negative 4x and multiply by everything out in front. So negative 4x times x is negative 4x squared. Negative 4x times negative 2, doesn't that turn into a plus 8x? Are you with me so far? But now what do I do? Subtract the whole thing. So this now becomes a plus, and this, don't do this. If you want my advice, don't, kids always do this. That's still a plus to you. If it's a plus and you need to change it to a minus, I literally scribble it out. Otherwise, you're always going to think that it's a plus. And now look, those first ones canceled just like they're supposed to. That math problem is hyping you up, saying, look at you, you keep going, you ball of sunshine. And now 9x minus 8x is just x. Bring down my last number. Yeah, go so fast. I'm almost done. What do I multiply x by to get x? A positive 1. So I put a positive 1 up top, multiply it through. And now I subtract everybody. Minus, and you're now a plus. First one's cancel. This one just so happens to have a remainder of 0. So that just means that x minus 2 divides into that crazy thing evenly. Isn't that nice? Let's do one. What'd you say? They won't be. Well, they're all lovely in their own way. Just like each and every one of you. Let's try one that has a remainder. So, oh, do we have an example 2? Example 2 comes out nice though. So let's skip to, let's do, I know that you have the answers right there. Pretend you don't see them. Let's do number 2 on the back where it says practice. And pretend we don't see the answer. In fact, I'm going to cover mine. No, I won't. It takes up too much space. Yes, I will. No, I won't. I'll just scribble it out. You don't see that. Okay. All right. So we're going to do number 2. So let's see. I need to have 2x minus 1 on the outside and then on the inside. Before we write it, are we going to need any 0 placeholders with this one? No, I have 3, 2, 1, none. So that's exactly what I want. So you go ahead, you try it. This one, as we know, is going to come out with a remainder. So get as far as you can. And then we'll, I'll show you how to handle the remainder. Make sure you keep everything in the right columns. Okay, when you're done, just check and see if you have what I have so far, and then we'll talk about that remainder bit in just 1 second. But if you don't end up, you should end up with a remainder of 1. If you're not having a remainder of 1, you made an error somewhere. How are we doing? Do we get that remainder? Okay, great, great. Now, all I have to do to write our final answer, just like when it was numbers, whatever that remainder is, I'm just gonna add that on as a fraction. So I'm gonna add on my remainder of 1 over whatever you were dividing by, 2x minus 1 in this case. So that whole thing is now my answer. Okay, so the remainder part looks a little weird, but that's all it is. You just take, and you know it's a remainder when you're out of, you don't have anything left to bring down. I've done everything. If it comes out as 0, great, it's divided evenly. If it doesn't, now you have a remainder and you just throw it over whatever the divisor was. Add it on as a fraction of 1. What if that remainder is negative? Same thing, you would still add a negative, or you can just turn that into a minus sign. Either way, same thing. Thoughts? Easy? Try number 3. Again, don't look at the answers. Pretend you don't see it. What do you have to do on number 3? What?
Oh, placeholder.
Yes, this time I need placeholders. Let's talk about it. Yeah, see how I have x to the 3rd? I need to have every degree represented after that. So I need an x squared. So I have x to the 3rd. I don't have an x squared, so I put in 0x squared. That's called a placeholder. I don't have an x term either, so I'm going to have to put in a 0x as well. And then I'll have that plus 1. So it is the same polynomial. I haven't changed its value, right? Because those are just zeros. But now it's everything, it's literally a placeholder. So now I have everything will still line up perfectly. Okay, so give that one a try. And you're going to work with it being a 0, just like you normally would. 0 is a number like anybody else. Did you check your work against mine? So now I'm here. I have a remainder of 2. So I need to just add on to this 2 over whatever I was originally divided by, x minus 1. And that whole thing becomes my answer. Ta-da! Isn't that fun? See, that's not so bad. I knew you'd like that. Okay, any questions about long division? Okay, all right. So on Monday, I'll do a very quick recap. We'll practice just a couple of problems of long division, and then we'll move right on to a synthetic division. And I will show you how to do synthetic division to get the same or similar results. Okay, so let us tuck this away.
Mickey Mouse.
Donald Duck.
Oh, no, can you like?
I get a mouse and a duck.
I was thinking like, oh, I thought it was. Yeah, I thought it was Mickey Mouse.
You guys are dumb.
You know what?